In this video, we'll look at NVIDIA's new Kubernetes AI scheduler, also known as the KAI scheduler. This was recently launched at KubeCon EU 2025. And this is an interesting advanced scheduler that will allow users to share the GPUs in a fractional manner. Um, let's first start by looking at how do you set up, install, and configure the KAI scheduler and what its dependencies are. So let's look at a demo of KAI scheduler in action. So I have a Rafay Kubernetes cluster called Mohan GPU cluster. This is running Kubernetes 1.32, and this has got a single GPU in it. Let's go look at the GPU very quickly. It's got a single node, and let's go explore the labels to understand a little more about the kind of model we have. So this is running an NVIDIA T1000 and it's got 8 gig of GPU memory in it. All right, so now let's move on to what else we have deployed on it. As you can see here, we've applied a custom blueprint called GPU metrics and is a version 6. And if I go look at my GPU metrics blueprint, this has a bunch of things in it. It has the NVIDIA GPU operator, and we've also deployed the KAI scheduler on it. Let's go look at that in a little bit of detail. Now the blueprint synchronization says it's successful, so let's go look at that. And as you can see here, a bunch of add-ons have been deployed. The namespace called GPU operator resources is a standard namespace for the NVIDIA GPU operator, and this has been deployed on it. And then we've also deployed the new scheduler from NVIDIA called the KAI scheduler, Kubernetes AI scheduler, and this has been deployed onto a namespace called the KAI scheduler. So that's essentially the setup. This takes a couple of minutes to set up. Now, there's a couple of namespaces here that may be worth knowing. So let's go look at that. We'll use the inbuilt Kubernetes dashboard. And if you go look at the GPU operator resources, there's a bunch of things that are deployed here. And then the KAI scheduler, if you go look at that, it has 3 core pods in it. Now, the other thing that will also get created, which is associated with the KAI scheduler, is a namespace called Run AI Reservation. Now, this by default will have nothing in it, right, at this point. And if you go look at this cluster, if you notice, although I have a GPU, nothing has been committed yet, right? So now what we're going to do is we're going to look at a couple of models by which I can share this GPU, a single GPU, with multiple applications. Now, in a traditional way, I have to allocate an integer. So since I have one GPU, I have to allocate the whole thing to a pod, and which means that the remaining pods will not be able to be scheduled. Now, there are 2 strategies that we'll look at in this particular video. The first strategy is called a fractional GPU allocation. And in this model, imagine if you have a single GPU, NVIDIA GPU. Imagine if you have 3 applications that need to use a GPU, but you only have one. So with this approach, you'll be able to allocate fractions. In this example, we have 3 fractions. The first fraction is consuming 50% of the GPU. The second one is consuming 30%, and the third one consuming 20%, totaling up to a single GPU. So what does it look like? If you're an application, and imagine if this is your pod spec, as you can see here, before KAI scheduler, you're required to specify integers in your requests and limits. In this case, I specified 1. With the KAI scheduler, KI scheduler, you basically don't have to worry about setting that at the resource request limit level. You just put in an annotation called the GPU fraction, and I'm specifying 0.5 here. And notice in the spec, we are asking it to be scheduled by the KAI scheduler. So let's go look at our code here. So the first example we're going to look at is a fractional approach. The strategy here we're going to use is a GPU fraction. As you can see here, I'm basically saying, hey, please allocate 0.5 of that single GPU I have, and use the Kai scheduler, which is a custom Kubernetes scheduler, and run this container. So let's go run it. So I have a GPU fraction one.yaml. So let me go run that. So I'm just going to do a kubectl apply -f GPU fraction one.yaml. And this has been created. Now let's pivot to our dashboard and let's go look at whether everything is going well or not. And if you go look at the default namespace, because I didn't specify a namespace, it'll get created here. GPU fraction one has been created, is running. And if I go and exec into that container and I run the NVIDIA SMI command, notice it's running. Let's make it a big screen so you can see the whole thing. NVIDIA SMI. And as you can see, it's able to access the GPU and everything is good. Now, if we go look at this pod and we go describe the pod, because we want to make sure that this is not the only thing that can be deployed onto this cluster for this GPU. Notice there's an annotation called GPU fraction 0.5, right? So that's been set up. And so now what I'm going to do is I'm going to pivot to the second one, and I'm going to apply the second fraction. And this is essentially going to ask for a different set of resources. Let's go see that. So here, notice this is only asking for 0.2 of the GPU, which means out of the one GPU, 0.5 was consumed by the first one, and the first pod that I deployed, and the second one is going to consume 0.2. So let's go try this. And when I go apply this, notice that it's the pod's been created. And if I come in here and refresh this, you'll see that my second one is being created. Now, if I go look at my, if I just do a container exec and I run the same NVIDIA SMI command, again, it's able to do that. And then if I go and describe the YAML, notice that it's asked for a GPU fraction of 0.2 only, right? So in a sense, what I've done here is this GPU that has a single one, and notice is a single GPU has been allocated. Now let's go look at what is actually using the single GPU, because there are two pods now. But as you go look at it in our integrated GPU dashboard, what is actually consuming the GPU is this new pod that's running in the run AI reservation namespace that I showed you, right? So if I go look at this particular pod, and I go pick this run AI reservation namespace, and notice there is a single pod that actually is servicing both of them. So if I go look at this pod and I go and describe, and if I go look at the details here, this is NVIDIA's advanced schedulers component, and you notice here this is attached itself to the single GPU. So although this is attaching to a single GPU, the pods themselves get a fraction of that. The first pod is getting 0.5, the second one is getting 0.2. So that's approach number one for a model where we are able to run two pods. Let me go remove this filter. There's two pods, each running a fraction here. There is a second strategy, that we'll also look at in this video, which is fractional GPU memory allocation. And this is a little different from the first strategy. So imagine if you have a GPU, and in this case, I'm showing an example with 4 gig of memory. Now, maybe I have 3 applications that want to use this GPU, but they all need different memory. They all have different memory requirements. In this example, the first fraction, this wants 2 gig. The second one wants 1 gig. So does the third fraction. So how do I specify this? Again, we saw how this is done before without the KAI scheduler. With the KAI scheduler, again, in the spec, you point to the KAI scheduler, and in the annotation, you simply specify your GPU memory requirement as, in this case, 2000, which is 2 gig of memory. That's pretty much it. And we'll see demonstrations of both in action in a few seconds. Now we're going to pursue a second strategy where perhaps instead of simply doing a fraction of the GPU, where the GPU can have any level of memory, doesn't matter. Maybe you want to take a different strategy here. And in this strategy, we're going to do fractional memory, GPU memory. So here, my GPU has 8 gig of memory, out of which I want this pod to only consume 2 gig. And I'll have a second pod, which perhaps will consume a different fraction. Let's go look at that. And in this case, it's consuming 1 GB, right? So let's go make this happen. So let's go back to our cluster. And as you can see here, everything is clean. If I go to my, if I kubectl into my cluster and I go look at the default namespace, there's nothing in it at this point of time. So let me go and run this first command. So I'm going to do this memory fraction YAML. So kubectl apply -f. So we're going to apply that, and we'll also go ahead and do the second one to save time. And the second one also has been created. Now let's go into our Kubernetes resources dashboard and go into our default namespace. And you can see here, the fraction 1 and fraction 2 pods are running. And if you go describe the pod, if you notice, this is asking for a GPU memory of 2 gig, and the other one is asking for a GPU memory of 1 gig. And in this particular case, although we are in total consuming 3 gig of virtual memory of the GPU memory, there's still plenty more room available. So I could, in theory, add a few more pods until I get to 8 gig. Now, if I go back to my cluster, notice this is went from green to red, which means, again, the running out reservation GPU pod would have kicked in. And that is the one that is now brokering access to that single GPU, but allocating fractions of that. In this case, I've chosen a strategy of allocating a fraction of the GPU's memory versus the whole GPU memory. So this allows me to pack more applications onto the same GPU and be able to share GPUs effectively and save costs. Thank you.